Hello, my name is Bahjat Kawar and I will be presenting our work on Imagic text-based real image editing with diffusion models. So the goal of our work is to edit real images using text. For example, given this image of a dog and the text a photo of a sitting dog, we would like to obtain an image like this one. And the way we do this is that we take a pre-trained text-to-image diffusion model and we use it to find and optimize for an embedding that describes our image. And then we take the optimized embedding and use it to fine-tune our diffusion model to better capture the image specific appearance. Then finally, we interpolate between the optimized embedding and the target text embedding to obtain an image that semantically describes the interpolation between the text and our input image. So starting off with some background, text condition diffusion models or text-to-image diffusion models are great generative models that can condition the generative process on some input text. They control the generation via this input text using knowledge from large NLP models, and they obtain great photorealism and text alignment. And the way they work is that they condition the diffusion model on a text embedding describing the target image. And that's how, given input text, we can generate an image. The model is trained using a dataset of text-image pairs. Now, in Imagic, our goal is to obtain image editing using these diffusion models. We want to edit real images using a text prompt. So for example, given this real photo of a dog and the text a photo of a sitting dog, we would like the diffusion model to be able to edit this image into a photo of a sitting dog while preserving the identity of the dog and the overall background and composition of this image. And this is, for example, a real output of Imagic. Now, the way this works is that we start off with a pre-trained text-image diffusion model. We take our input image, we add some noise to it and input it into the diffusion model. Diffusion model will try to denoise it, and we use the traditional diffusion reconstruction loss between the output image and the input clean image, and we optimize this reconstruction loss. We backpropagate through the diffusion model into the text embedding, starting off from the target text embedding and searching for an optimized embedding, EOPT, that should semantically describe our input image. Now, after this step, we obtain an optimized embedding that is semantically close to our image, but it does not match it exactly. So we take it a step further and take this optimized embedding and use it to fine-tune the diffusion model itself on the same reconstruction loss, thereby obtaining a fine-tuned diffusion model that can now, using the optimized embedding, reconstruct our image perfectly. And then we take this fine-tuned diffusion model as well as the optimized embedding. We interpolate between the optimized embedding and the target text embedding through spreading wings, and use the fine-tuned diffusion model to obtain a generated image. Generated image matches the semantic interpolation between the text and our input image, giving us the same bird, only spreading wings. So the fine-tuning of the model is necessary because here we can see in the top row, as we go more towards the input text, we lose the characteristics of the original image of the cake. Whereas in the bottom row, using the fine-tuned model, we preserve the overall structure of the image all the way until the end, and we can obtain the same cake only in a pistachio flavor. Here are some more results from Imagic. For example, here we can edit two objects, two kissing parrots. We can make this person give us the thumbs up, and we can turn this cake into a chocolate cake. As you can see, Imagic works really well. Here we edit the same image using multiple prompts. So for example, the dog can be sitting, jumping, lying down, or playing with a toy. The person can give us the thumbs up, cross their arms, or hold a cup. All very high quality images. Our edited images are all 1024 by 1024 pixels, so it's very high resolution, and we can apply a variety of edits. As we can see here, the edits can be for multiple objects, they can be for style, for color, for pose. Anything we can describe with text, Imagic can apply these edits, as we can see here. And since we use a stochastic generative model to apply our image editing, even conceptually, it does not have to always give us the same exact image. So for this bird and a photo of a bird spreading wings, the bird can spread its wings in multiple ways. Even conceptually, it can do that, and our model matches this by just changing the random seeds. If you change the random seed for the generation process after the optimization and fine-tuning, you can get different results for the same input image and text. The same goes for the children's drawing. Each child can draw this forest in a different way, and all of them are viable outputs that Imagic can give us. Here we apply Imagic on a publicly available stable diffusion model, and we can see that by changing the interpolation hyperparameter in the final step of Imagic, we can obtain semantically smooth interpolation where the chair moves into a wooden chair and back, the car moves into blue and back, as well as the flowers that turn into tulips. All can be done very smoothly, which is a nice property. I would finally like to thank my collaborators on this work, Shiran Zada, Oran Lang, Omer Tov, Waiwen Chang, Tali Dekel, Mbar Musseri, and Michalia Irani. And thank you for listening. For more information about Imagic, please check out our project webpage using this link or the QR code.